Let's learn about 8.2 today, similarity. Now, similarity I had kind of defined for you guys already in lesson 8.1. Today we're going to actually go ahead and solidify my description and give you the characteristics of what similar figures or polygons are. All right. So polygons are similar if, number one, they have the same shape, of course. Number two, if they're congruent corresponding angles. So if they're angles that are corresponding, if they're congruent, it's going to be similar as well. And last but not least, the corresponding sides are proportional. Now think about what proportional means. Proportional means that when you take the ratio of two sides of one polygon and you set it up to the ratio of their corresponding sides, you're going to have equal ratios. You're going to have cross products that are equal. It does not mean that they have the same sides. It does not mean that they are the same size. It does not mean they have the same length. It means that it is proportional. So to illustrate that, let's take a look at the following. We got triangle ABC. Now, triangle ABC is right there for you. It's an 8, 10, 12 triangle. Okay? It is similar to triangle DEF. Now, in this particular case, we don't know if DEF is larger or smaller, but we are going to know that angle A is going to be congruent to angle D. Angle B is going to be congruent to angle E. And angle C is going to be congruent to angle F. We know that not by the figure, but we know that by the letters. So, okay, here we go. Triangle DEF is similar to ABC, and let's prove it. Okay, we know that A is congruent to D, so this guy's work. We know that B must be congruent to E, so these two guys work. And we know that C must be congruent to F. So far we're on target. Now, yes, sir.
Why would there be the 3 tick marks, a 2 tick mark, or a 1 tick mark?
Okay, they're proportional. And you're right. They are not congruent. They shouldn't have the same exact tick marks. But in this case, see the tick marks is not as congruency, but as correspondence. Thank you, son. That's a very good point. Good job. Now, let's look at the ratio of the sides here, okay? AB corresponds to DE, right? So, 8 to 4 is the correspondence ratio. AB is 8, which corresponds to DE, which is 4. You with me, guys? So, if A corresponds to D, and that's the ratio, all of the other corresponding sides better have the same ratio. So since I started with the larger triangle, let's continue with the larger triangle. Now let's go AC to DF, which are corresponding, 12 to 6. And that better equal also the last side of the larger triangle, which is BC 10, to corresponding side EF 5. In the end, all of these equal 1/2. And that's right. It's not 1/2. I was testing you guys, and you did well. It's 2/1. Sorry about that. Okay, I apologize. Okay? Does that make sense, guys? Now, I could have done these ratios a little bit differently as well. I could have said the following. I could have said, okay, 8 to 12 better be equal to 4 to 6. Why? Because 8 and 4 are the correspondings, and 12 and 6 are the correspondings. I can also say, well, then in that case, 10 to 12 better be equal to 5 to 6. And when you do the math there, they are all equal. Okay? This guy is proportional to that guy. This guy's proportional to that guy. All the sides are proportional. So you could take sides from the same triangle and set it to the corresponding sides of the smaller triangle. Or you could do what we originally did. Large side to small side, then large side to small side. Depending on how you want to work it. Depending on what makes sense for you. Does that make sense though? No, it doesn't. 8 to 12 equals 4 to 6. That was one proportion that was congruent. Thank you, son. And then in that case, let's not confuse anybody. Let's get rid of that. And then 10 to 12 must be equal to 5 to 6 because those are corresponding as well. Does that make sense, guys? And then, well, let's just finish it up then. So then that means that 8 to 10 better be equal to 4 to 5. So you could do it this way or this way. Does that make sense? You good? Okay. Now, we have, in this particular situation, we started with ABC and we went to DEF. And we went from a larger triangle to a smaller triangle. Well, that is called a reduction. There are two ways that you can either amplify or reduce any polygon. If you are going to amplify it, make it larger, that is called a dilation. Okay? And a dilation is right here. Increasing size by multiplication. If you decrease the size, though, gentlemen, then you have what's called a reduction. And that is decreasing size by division. So if you ever hear in the doctor's office, in the eye doctor, oh yeah, my eyes are dilated. They put like a little chemical, like an eye drop, that on purpose increases the size of your pupil so they can examine it. Okay, that's why my eyes are dilated. They increased it. Okay. Reductions are seen in model planes and model cars and model toys. You see, a real Mustang, and then you see a Hot Wheels Mustang. When you look at it, you're like, it looks almost exactly the same. Well, it is. They used a scale and they used a reduction. Maybe on this little tiny Hot Wheel car, maybe the scale was, I don't know, an inch equals 7 feet, maybe. So maybe the whole entire car is 14 feet long, but the little model is only 2 inches long. But it is a proportion. It is either going to be a dilation or a reduction. That's where proportions are used. Just like a map. Okay, we had talked about that yesterday. A map of Florida I can fold up and put in my pocket. Yeah, there's no way on earth that I can fold up the girth of Florida and put it in my pocket. But it is calculated using scales, using proportions. So in that case, going from a real landmass to a map, that would be a reduction. And maybe I reduced the actual land masses, I reduced it by, I don't know, by 1 million square feet to make that map. But every single distance was reduced by that amount. Does that make sense? Yes, sir. Girth, size. The size. Okay. We're going to go ahead and break for a second, and we'll be back in about half hour. Thank you, guys. All right. Now, let's see how we can apply what we just learned about similar figures. In this first example, it's in your book on page 332. It says a pinhole camera produces a reduced image of a candle. The size of the image is proportional to the distance of the candle from the camera. Given the measurements shown in the diagram, find the height of the camera. Okay. First off, you have to realize that they're talking about two different triangles. This triangle right here, which we will outline in red, and this triangle right here, that we'll outline in blue. They tell you right from the bat that the height is proportional to the distance from the candle to the camera. Okay, it's proportional. So they're telling you already that the sides are proportional. There are two triangles, the sides are proportional, so they're going to be, for sure, similar. Now there are two ways to set up this proportion. Okay? You can say height of the large triangle, which is what we don't know, to the distance, okay, from the large candle to the pinhole, which is 20. And you make a proportion, you set it equal to the height of the smaller triangle, the height of the smaller candle in this case, to the distance of the smaller triangle. And now you just cross multiply. 5h equals 40. So the height of the candle is 8 centimeters. Now you could also do it another way. There are different ways to do this. You could start with, okay, let's go. The distance from the candle to the pinhole of the large triangle is 20. Related to the corresponding distance from the pinhole to the smaller candle. And you set that equal to the height of the large triangle to the height of the small triangle. Cross multiply, h will also equal 8. You could also say, okay, how about if I want to reverse it? What if I want to say 2 to 5, small triangle height to small triangle distance, equals h, large triangle height, to large triangle distance. You're still going to get that h equals 8 centimeters. Does that make sense? So the key here is not to follow what Mr. Morrow does. The key here is to understand the relationships of corresponding parts. Height of the large triangle to distance of the large triangle, you set that to the corresponding side of the small triangle. Height of the small triangle to distance of the small triangle. You always relate it. Corresponding sides. Does that make sense? Yes? Okay. Let's move on. Okay. Excuse me. For example 2. They give us all of the following data here. Okay. I've got 2 different triangles here. And they tell me that MCN, which MCN we're going to outline right here in red, is a dilation of MED. So first of all, if it's a dilation, that means that it's larger. Well done, son. So MCN is definitely larger than MED. MCN is a dilation of MED. And they tell you that it has an enlargement ratio of 2 to 1 for each pair of corresponding sides. Find the length of the sides of MC. Okay, well this is really easy. Bless you. The distance of ME is 4, correct? The distance of MD is 3, correct? Do you guys remember the Pythagorean triples? Remember the most popular Pythagorean triple is the 3, 4, 5. So if you know the 3, 4, 5 Pythagorean triple, then you know that ED is 5. If you did not know that, set up the Pythagorean theorem. 3 squared plus 4 squared equals ED squared. This is 9 plus 16 equals ED squared. This is 25 equals ED squared. Take the square root of both sides. 5 equals ED. It's actually plus or minus, but you can't have a negative, so ED is 5. But it's a lot easier to know the Pythagorean triple. Yes, sir?
Can't you pass triangles?
You're not assuming a right angle. Thank you, son. This is a vertical line with a slope of 0. That's the y-axis. The x-axis is a horizontal line with a slope that is undefined. So that means that their slopes are negative reciprocals of each other, and you have a 90-degree angle right here. I did not assume anything. The cross-section between the x and the y-axis is always a 90-degree angle. So now, yes? If the x and y-axis was not there, then we'd have to prove that it was 90 degrees. Yes, sir. But in this case, they gave us an x and y-axis, sir. So now, they tell us that MCN is a dilation with an enlargement ratio of 2 to 1. So if MCN is 2 to 1 of MED, what would MN be now? 6, because you multiply by 2. What would CN be? 10, because you multiply by 2. And what would MC be? 8, because you multiply by 2. Does that make sense, gentlemen? So that's a dilation. And again, it's really good to know the Pythagorean triples. Remember, a couple popular ones are the 3, 4, 5. You also have a very popular one that is 5, 12, 13. You also have another very popular one that I believe is 7, 24, 25. Those three are really good to know. There are infinitely more, but remember that not only do the 3, 4, 5, 12, 5, 13, and 7, 24, 25 work, but all of the multiples of those. So if I were to give you a 10, 24, the hypotenuse would be 26 because I multiplied it by 2. It's multiples of the triples. That make sense?
Yes, sir.
Yes? All right. May I continue?
Yes, sir.
Thank you. Okay, now, Theorem 61. Let's put this all together now. For Theorem 61, it says that the ratio of the perimeters of two polygons equals the ratio of any pair of corresponding sides. Think about it. If you've got a triangle that's, let's just say a 3, 4, 5, okay? And you've got a triangle that's a 6, 8, 10. The perimeter of 3, 4, 5 would be 12. The perimeter of a 6, 8, 10 would be 24. Isn't that 2 times the original perimeter? Guys?
Yes, sir.
Yes, right? 24 is 2 times 12, correct? And if I'm comparing a 3, 4, 5 and a 6, 8, 10, isn't the 6, 8, 10, doesn't it have a dilation ratio of 2 to 1? So the ratios of perimeters of two similar polygons equals the ratio of any pair of corresponding sides. Okay? All right. So, problem 1. They give you that triangle JHK is similar to triangle POM. They give you that H is 90 degrees. They give you that J is 40 degrees. They tell you that the measure of angle M is X plus 5. And they tell you that the measure of angle O is 1/2 of Y. And they want you to solve for X and Y. Well, the first thing, I apologize, I should have hidden this from you. But the first thing you got to do is figure out that K equals 50, and that's easy. Because 180 minus 90 minus 40 gives you the 50. Now, since they tell you that they are similar, what angle is K equal to? M, yeah. K corresponds with M. They're similar, they're congruent. So don't I know that 50 equals X plus 5? So correct, I heard it out there. X equals 45 degrees. Perfect. Now, since they're similar and H is 90, What does the measure of O have to be? 90. So doesn't 90 equal 1/2 of y? So y equals 180. I heard someone say 45. Be careful. You get rid of the denominator of 2 by multiplying 2 to both sides. So those cancel, and y equals 180. All from knowing that they were similar. Does that make sense, son? May I continue, gentlemen?
Yes, sir.
Yes, sir.
Theorem 61.
No, Theorem 61 had nothing to do with this. This had to do just with similar triangles. Okay. Theorem 61 has to do with the following. I had already explained this, but apparently we were not listening. So what we'll do is we'll do it again. Now, if I tell you this is 90 and this is 90, and I tell you that this is A, B, C, and I tell you this is D, E, F. I tell you this is a 3, 4, 5, and I tell you this is a 6, 8, 10. Okay? As far as the sides go, what is the reduction ratio from ABC to DEF? 1/2, guys. Yeah, look. 4 to 8 equals 5 to 10, which equals 3 to 6. So it's 1/2, correct? What is the perimeter of ABC? 24. What is the perimeter of DEF? 12. Isn't the ratio of the perimeters, which is 12 to 24, doesn't that equal the ratio of the sides? So if I have two similar polygons, okay, if I find the ratio of their corresponding sides, that's going to be the exact same ratio of the perimeters. It's not going to give you the value of the perimeter. It's just going to give you the ratio of the perimeters. Does that make sense, son? You sure? Bless you. You sure, my man? Thank you, sir. Okay. So let's go back here to where we wanted to go, which would be here. Okay. Perfect. Now, in this bad boy, we got triangle BAT, which I'm going to go ahead and outline that bad boy in red. Okay? And I have BAT being similar to DOT, which I will highlight in green. They give you that BT is 12, they give you that OT is 15, they give you that DT is 9, they give you that AO equals X, and I need to find X. Don't think of a formula, think of the logic that I use. Check out what I'm going to do. 12, which is the side, one side of the large triangle, to 9, because they correspond. That must equal X plus 15, which is the largest side of the large triangle, to the larger side of the small triangle. Does that make sense? You could have also set it up like this. Large side to large side of the large triangle equals the smaller side to the larger side of the smaller triangle. Either way, I promise you, you're going to get the same answer. When you go ahead and cross multiply here, gentlemen, you get 180 equals 9x plus 135. Subtract 135 to both sides. You got 45 equals 9x divided by 9. X equals 5. you would still have x equals 5 if you calculated it that way, the exact same value. Does that make sense, gentlemen?
Yes, sir.
And look at the way I did it. I didn't do it using a formula. I used corresponding sides. Again, either the smaller side of the large triangle to the smaller side of the small triangle, that's 12 to 9. Then I corresponded to the larger side of the large triangle, x was 15, to the larger side of the small triangle, 15. Or I take each triangle individually. Small side of large triangle 12 to large side of large triangle x plus 15. I set that equal to small side of small triangle 9 to large side of small triangle 15. It's just a matter of how you want to interpret it. Does that make sense, guys?
Yes, sir.
You good, my man? All right. May I continue, gentlemen?
Yes, sir.
Thank you. Okay, last but not least, in this diagram, okay, segments PA, PB, and PC are drawn to the vertices of ABC from an external point P. Okay, so we have this ABC. Okay. And then they're extended to 3 times their original lengths to points A prime, B prime, and C prime. What are the lengths of the sides of triangle A prime, B prime, and C prime? Well, they tell you that AC is 15. They tell you that AB is 12. And they tell you that CB is 10. If they are telling you, okay, that they are dilated, they're getting larger, okay, they have a dilation ratio of 3 to 1. So if I have a dilation ratio of 3 to 1, what would A prime, B prime be? 36. What would A prime, C prime be? 45, because you multiply by 3. And what would C prime, B prime be? 30. All because I had a dilation ratio of 3 to 1. Does that make sense?
Yes, sir.
All right. Well, that's it, my friends. Hope you enjoyed.